Yeah. Now, here, uh, that knowledge engineering, under that only, this all these domains are coming.
Mm.
It is like a max. Under max, how you are having algebra, calculus, like that, these all domains are coming. Here, K means data, E means algorithm, or we can call it as an intelligent.
Mm.
AI is nothing but an artificial intelligence. It is nothing but the mimic the behavior of the human. It will be come into the picture in
Yes.
1940. Earlier, it will come into the picture. Then machine learning will come into the
Mm.
picture in 1980, and deep learning will come into the picture 2010. Artificial
Mm.
intelligence subset is a machine learning. Machine learning subset is a deep learning. We can call it artificial
Yes.
intelligence as a car. Machine learning is a luxury car, and deep learning is a autopilot car.
Yes.
Now, you are having a Swift car, you can't able to climb, it is a luxury car. But you are having a BMW car, you can call it as a luxury car,
This is
but you can climb it as a car, but you can't able to climb it as an autopilot car. But you are having Tesla car, you can
not.
climb anything. Okay. Suppose you are
Yes.
doing a project in an AI, you can't able to climb it as a machine learning or deep learning. But you are doing a project
It's
in
not
deep learning,
intelligent.
you can able to climb it as a
It
machine
is
learning, AI, everything you
DNA
can
and
do
machine
that.
learning and artificial intelligence.
Now, what is the difference between AI and ML is that learning is a different. In
Yeah.
artificial intelligence,
But
there is no
learning
learning
is more
part.
advanced than AI, right?
Yeah, it is advanced than AI. How the things it will come means, for example, you are playing a chess game in a computer,
Mm.
and most of the chess games are AI based only. Machine learning also coming, but very rare now. These AI games are how the thing means. One four five programmers they sit, they code it, and they developed it. Okay, with algorithm, calculation, everything. They freeze it. Now we are moving a coin, it will also move the coin. Okay. But it have one flaw. I'm keeping a queen in one particular place. It is not calculating it properly means. Then I know that weak point. I can tell to all my friends, anybody can able to win that game. Got it? No.
Mm.
That is a problem of the AI. Whereas a machine learning, deep learning is like that. For example, you are having a one younger brother. You keep for assumption he is intelligent than you. He doesn't know chess, you know chess. You are teaching him a chess, how to play. Then what will happen? Slowly he is learning. One time you start winning, you start losing, you can't able to beat him. Correct? No?
Yes.
That is a machine learning, deep learning. In another words, how we can able to tell us an learning means you are doing a task. The task give an output performance. That performance
Mm.
give an output experience. This experience will help you to do the task next time in a better manner. For example, in a plus two exam, they will conduct the 3-4 revision test. Maybe max revision you can take. First time you are writing a test, that is a task. For that you are getting a mark, 50% mark you are getting that. That is a performance. That 50%
Okay.
mark will give an experience that next time how to improve the task.
Yes.
Like that we can able to
Like
keep
when we
on
are doing
doing
that
that.
the
We
second time, like yeah,
Hmm.
we are improving a lot.
Yeah. And what we can able to do means we can't able to make all the students get 100% mark, but we can able to optimize them. What is the maximum output from him? We can able to get it by doing this task. Some student may be
Yes.
saturated at 70% only. Some may be saturated between 75 to 80. Some may be saturated between 95 to 100. Like that, we can able to saturate that. Got it? No.
Mm.
Now,
Yeah.
in the early 1980s, they invented the face recognition. That face recognition they invented with the artificial intelligence, like this. For example, you saw it in many 1980, 1990 movies. Whenever criminals are entering into the prison, they'll take the photos of the criminal in a three profile, straight to left to right. It is a grayscale
Mm.
photo they will take. Then from the eyebrow to mouth, they will cut it. Okay, eyebrow to mouth, they will cut it. Then what they will do means it is a 80 by 80 pixel. Then divide it into 20 equal vertical segment and 20 equal horizontal segment. Totally, they will make it 400 segment. They will make it so that each thing will have 4 by 4 pixel. 16 pixels will be there in each segment. Like that, they will store the photos in a database. Maybe 1 lakh criminal photos are there. Like that, you can assume that. Now, one inspector is coming with a one suspect photo. You want to match with the which criminal is matching with the suspect photo. Same rules will be applied, and it has to take that one by one face image. It has to compare the thing. It will take 400 computation. It will take so that is a time consuming. It will take more than 1 day time to achieve this. So that it is a very difficult. So that they come up with the next thing, machine learning. In this machine learning, what they're telling, no need to compare all the pixels. We need particularly some features. What are the features? For the face recognition, we need the eyebrow, eye, nose, mouth. Only with this feature only we can able to identify. Why we have to compare all the things like that? They given one idea. They develop the technology. It is quite less in a competition, and it is a fast. Here the faces will be straight. Here face will be little bit tilt. Also it will recognize the like that. It will advantages are there. He is having a mustak without mustak also it recognize. It will. It is not like that. That is a machine learning will come into the picture. Then after the deep learning will come into the picture. It is called a neural network. Neural network means how the human will be working on that. You will also recognize your father, mother, your friends with this feature only. But definitely you will not scan all the features. It is not needed for you.
Yeah.
You will identify your friend within fraction of seconds. Some friend you will identify quickly with his nose. Some friends with his mouth. Like that, you will have the different classes for different features for different classes you'll have. That is called neural network. Neural network, how it will be come into the picture means this is a neural network architecture. You are having a input layer, hidden layer, and output layer. Three layers are there. Here, small circles are called there. No, this is called neurons. Usually, these neurons will get input from the previous layer, process the data, and send it to the next layer. Like that will do that. Now, assume that you are having a 2 years old baby in your home. You are training the baby to identify the dog and cat. What you are doing, you are showing that
Mm.
the 150 dog image, 50 cat image you taking. You shuffling that. You are showing the baby, this is a dog, cat, like that you're showing. In the baby's brain, something will form, some layers will form. That is called hidden layer. How it is forming, baby also don't know, we also don't know. Then after that, you are conducting a test to the baby by taking a 5 dog image, 5 cat image. You shuffle that, you are showing the baby, tell me what is this. Then baby will take some input, maybe number of legs, color of the animal, some input, random inputs. Then it will go to the brain and she will open her mouth and tell dog or cat, she will tell. First time training, baby can able to tell 4 correct, 6 wrong. Again, you train the baby so that
Mm.
gradually it will improve. After the 10th training, baby can able to tell all the things correctly. Here, the baby is called
Yes.
algorithm. You are showing the dog and cat image, that is called data.
Yeah.
Here, one baby need 10 training. Maybe another baby need 5 trainings only she achieve. Another baby, 100 a time you trained also, she will not detect it properly. Got it? No.
Yeah.
That is
Mm.
depends upon them. Here in the neural network, there are ANN, artificial neural network, usually will work for the numerical data. And CNN, convolution neural network. It is for the image processing. Then RNN, it is recurrent neural network. It is for the text processing. Like that, 3 network will be there. Since your project is coming under the face recognition, it is comes under the CNN. That is a convolution neural network will come into the picture. And your project is
Okay.
called supervised learning. What is meant by supervised learning? Supervised learning means labeled data. You are showing the baby dog and cat, you are showing that no. That is called labeled data. That is we already labeled the data and we are telling it's a dog, cat. That is called supervised learning. What is meant by another type is called unsupervised learning. What is unsupervised learning means in one folder, you are keeping all the dog image, all the cat image. You want to segregate dog separately, cat separately. That is called clustering technique. That is called unsupervised learning. But your project is a supervised learning. we are doing that supervised learning under the session, deep learning under the algorithm CNN, convolution neural network. Clear?
Okay.
Now we are going to the next one. What is convolution neural network? How it is going to work?
Yeah.
Okay. Convolution neural network. It is called convnet. It is called convnet. Convolution neural network. It is called convnet. It is called supervised learning to analyze the data. CNN applies to image processing, natural language processing. Also, you can do that. Majority they are using for the image processing classification. Now, a image. Whenever you are going to the image, a image is for us. It is a 2D, two-dimensional. Correct? Now, image means number of rows, number of column will be there. But internally, image will have the three channels: red, green, blue will be there.
Yeah.
So that image is nothing but it is a three-dimensional. We are having 100 by 100 images there. It is a 100 by 100 into 3. 3 means red, green, blue. You got it, no?
Yeah. 100.
Yeah. Now it is a three-dimensional. Actually, you are having one page. In that page, you want to point the word. It is a two-dimensional. Which row? Which word? How many word? It is a two-dimensional. You are having book means you need the page number, then row number, and the word count we need. Correct? No, that is a three-dimensional.
Yeah.
Then what do you mean by four-dimensional?
I come again.
I told you
Three
example for
dimensional
the
means what?
two-dimensional. Two-dimensional means in a page pointing the word. Which row, which column you are telling that is a two-dimensional.
Yeah.
Three-dimensional means
Okay.
in a book, which
Okay.
page number, which row, which column you are telling that is a three-dimensional. I am asking you the question, what is meant by the four-dimensional?
Four dimensional means like front of the page, like you can take back of the page, sides of the page, like
No.
top,
It will not
bottom,
come that.
left, right. We
You
can
have
take
to
it as
tell,
four, right?
you are having a stack of books you are having, then you have to tell which book, fourth book, third page, sixth row, seventh column. That is called four-dimensional. Even you having a front page, back page also, it will have the number.
Okay.
You keep
Okay.
that, assume that it's a number will be there. Now, you are having one image is a three-dimensional
Yeah.
in a computer field. When you are having a 10 images, 100 images, it will become a four-dimensional, it will come into the picture. It will come, how it will become into the picture is, we'll mention like this.
Mm.
1000,
Yeah.
comma,
Now I
100,
understand. Like
comma,
there is a four
100,
books, like
comma,
we
3.
have to
Like
tell
that
in
we'll
the
mention.
fourth book, third.
Yes. Fourth book, sixth page, seventh
Okay.
column. Sorry, sixth page, seventh row, eighth column. Like that we have to tell. Okay. Here, this will represent the image. How many images are there? It will tell that number of rows. It will tell number of columns. It is a channel. Which channel? RGB. Any color you are taking that, it is having a RGB will be there. You are taking any color, it will have the RGB will be there. Red, green, blue.
Okay.
Got it, no?
Yeah, I got it now.
Now, now our project. This is one example. It is not your project, just one example. It is a handwritten recognition system. For understanding the CNN, we are giving one example in a PPT, very simple form. This system going to explain you. You are giving handwritten X and O. It has to tell that whether it is X or O. Here, number of classes will be 2 because X and O. Usually in alphabet, 26 classes will be there. But here we are going to do that X and O only. Here, this X is a input and output X is it is a handwritten is a input and class will be the output. Here the hidden layer will be 4 layers are there. Convolution layer, RELU, rectified linear unit, pooling layer, and fully connected. Four things are there. Actually, these things are not necessary for you to explain to your guide, but you know all this idea, your confidence level will be boosted. You can able to talk with your guide very clearly. For that, I'm explaining you. Even I have separate video for this also. I'll share that video also to you. You watch that video a couple of times, you'll understand it quickly. Okay. Now,
Yeah.
what will happen means this is a for each class we have to collect that the number of images we want to do. In your project, for example, celebrity face recognition, we are doing Amitabh Bachchan. One is Virat Kohli. I need a minimum Amitabh Bachchan. One 10 images of Amitabh Bachchan I need. And 10 images of Virat Kohli I need like that. Now, what we have to do means we have to identify which are the year wherever they will convert into black and white. In that thing, wherever black will be coming, they will make it as a one, and wherever it is coming that the white, they will make it as a -1. Now they will overlap
Minus one. Okay.
all the data set. They will overlap 1 over 1 over 1 over overlap. They'll find that the common features. For X, the common features were, in this example, we are taking a three features like that top left to bottom right, and this X, and another one is a top right to bottom left. Like that, we are having that the three features for X. For O, you will have the different. Definitely, O will not have this thing, a cross cutting and the diagonal things will not be. In O, we have the curve, we will have that the straight lines will be there. Like that, we'll have the different. Now, these are the three features. Now, what is going to happen means it is a given one input image. On that input image, we are having three features. We are processing one thing called convolutional. It is called nothing but a matrix multiplication. We are going to get, it is an 8 by 8 matrix. It is a 3 by 3 matrix. We are doing a matrix multiplication. We are getting the 8 by 8 output. We are going to get it here outside. How it is going to happening? It is a calculation not needed, but I will explain you how the things are happening. Now, this is a one feature. In this feature, for this value, we are calculating 1 into 1, 1. -1 into -1, 1. -1 into -1, 1. Like that. -1 into -1, 1. Like that. 9 once divided by 9. There is a 1 it will going to come. So that will become. Next one, we are going with the middle one, we are going to do that. It is a 1 plus 1, it is a 1 into 1, 1. -1 into -1, 1. -1 into +1, it become -1. Then it is coming that 0.55, like that. So that we are doing that process, we are getting that this output, we are getting it. Now, next thing is a RULU, rectified linear unit. What it will do means, it will keep all the positive values. Any negative values are there, it will make it as a 0. Now it is a negative
Mm.
value, make it 0. That's all. So that all the negative values, it will
That only
convert into the
applicable
zeros.
in RELU.
RELU, rectified, it is called activation function. They
Yeah,
call
yeah,
it as an activation
yeah.
function. It will be converting to the 0. Then next, another thing is called pooling layer. In pooling, we are using max pooling. In the max pooling, what it will do means, we can keep 2 by 2, 3 by 3. What will happen means, in this segment, which is the maximum, it will take that. 1. In this thing, what will the maximum? 33. Like that, it will be taken. So that what will happen means, after we are giving one image, after convolution, RUL and pooling, this 8 by 8 matrix will be reduced to 4 by 4. Now, in this 4 by 4, again I'm applying convolution, RUL, pooling one more time. This 4 by 4 will convert it into 2 by 2.
Okay.
Since,
Then
for
again you
example,
have to.
for example, we are taking
Why
8 by
you
8.
pulled?
Hmm?
Okay. Why you are pulling?
Yeah, we want to extract the features. You are having that the one apple. I want that strength of the apple. We will make the juice. No, we don't want that
Yeah.
unnecessary item. No, we are taking that the very very important things only. We are taking that.
Okay.
That is
Okay.
called feature extraction.
Only important. Like you will be
Important
filtering. Yeah.
filtering. Yes.
Mm.
So that in this thing, what will happen? We are beyond that. We can't do that. So that we are stopping that. It is a two-dimensional. We are converting this two-dimensional into one-dimensional. That is called fully connected layer. This one point
Fully
five five,
connected.
0.551, like that we are doing it.
Okay.
Got it, no?
Full. Yeah. Fully
We are
connected layer
having,
is the final
it
one.
is, this is the
Final output.
feature of the X. So that we are having a two class. For X, we are having one set of feature. For O, we are having one set of feature. Here, the main thing will be how many ones are coming is a very, very important. In this feature only, these are the predominant. 5 places, X will have the one. In this thing, 4 places, O will have the one.
Okay. So for where we are seeing the one, that is the place. Like
That is a very
the
important
X,
place. That
the
is
X.
important place.
Yeah.
Actually, you are seeing your friend. For one friend is Kumar, one friend is Ramesh, like that. One friend, R is very curly, will be there. That is a one predominant feature for recognizing him. Another friend is wearing a fix. That will be one feature for you, predominant feature for you, detecting is Ramesh. Correct? No, that is the one.
Hmm.
Then you will all the
Hmm.
fix will not be the thing. You are having fix, then nose will come, predominant feature will come like that. This is a, don't worry about this thing. It is a one idea only. I'm telling that these are internal works.
Yeah. Okay. Okay. Then okay. Then
It
I
is
will
these
take
are
it.
internal works. It is
For
no, don't worry about thing.
yeah,
How it is working, you have the one idea. It is like that. How gear we are shifting in automatic car, how gears are going like that. Maybe you know that in automatic car 60 gears are there. How gears are changing, we are not don't worry about that. We are going to drive the car only, but we have some idea, it will be useful for you. That's all.
yeah. Okay. Okay.
Okay. Now, next
Okay.
thing, you are giving one input image. For that input image also, we want to classify whether it is a X or O. For that also, it will extract the feature. Then, based on this feature will be compared with these two feature, which is more nearest. It will tell this belongs to that. How the comparison going to happen means it is a input image feature. This is going to compare with the X. X will have the 5 places one no. For that 5 places, what will happen? It will take that the 5 place value. This first place zero point 0.9 and the fourth place 0.87. Like that, they will sum up. It is a 4.56 coming, it is 5. So that it is a 91%, it is matching. Into 100, we have to make it. 91% input image is similar to X. Then another thing will be for O. O will be having 4 places. It is having a
Yeah.
51%, it is matching with the O. So that we can able to tell that whether it is a X or O means we can tell that it is an X like that. For example, I given you an example of the baby example, dog and cat. So that you are showing the dog and cat baby will tell after
Yes.
training.
Yes.
Suppose you are showing one cheetah image, what baby will tell? You are not trained that baby.
Good
But
dog
you are
like
showing the cheetah image,
yeah,
baby
yeah,
will
yeah.
tell it's a
So
cat.
the baby will tell like
Cat. Mostly it will tell cat.
yeah.
You are showing that the lion image, it will tell dog. Chances are there. But baby, we train only two
Hmm.
only. It will able to understand that only. But we are doing out of the thing, it will not, it will tell, I don't know, it will not tell. She will tell which is similar, it will tell like that. You got it, no?
Yeah, yeah, I got it now.
That is a machine learning, deep learning. Machine learning, deep learning is nothing but one small child we are training like that, it will be going to come into the picture.
Okay.
Okay.
Yeah.
Then this thing, same example, dog, cat example like that. Okay, now we are going for the
Yeah.
what are the steps involved in your project?
Hmm.
Then we'll go with an coding class.
Okay.
First one, we need the data collection. So that
Okay.
we have to identify with the number of class.
Hmm.
For face recognition, we will train with an on 5 face means you can keep maybe your face, your friend's face, like that you can add. But we are training with the celebrity photo. It is easily available in net. We are taking that one class. One maybe Amitabh Bachchan, another thing Virat Kohli, and some Aishwarya Rai. Like that we'll take it. Alia Bhatt, like that. Second thing will be the
Yeah.
data pre-processing. In
Okay.
this data pre-processing, what are the steps are involved means first thing is a resizing. All the photo we have to make it a same size. We have to make it. Some may be different thing will be there. We have to same size and we have to crop that face only. We have to crop it. That is a work. Then after
Okay.
that, after the resizing, here these values are coming. No, this 89, 103, 277 is there. No, here the all the things zero means black. All the thing 255 means white. So that what we are going to do means we are dividing all this value with the 255. We are doing that. So that it will be converted between the value between 0 to 1. It is called normalization.
Yeah.
We are converting
Alright.
into the floating point numbers for the more accurate
Yeah.
matching. That is called normalization.
Mm. Mm.
Now we can able to keep that. Your data will be like this. 1,000 images I collected like that. You can keep it.
Mm.
Each image is a three-dimensional. I told you no. It is a red value will be there, two-dimensional will be there. It is a green value will be there, and blue value will be there. Maybe we are having a one three class. Amitabh Bachchan, Virat Kohli, Alia Bhatt. Now we can keep that Amitabh Bachchan will be 0, Virat Kohli will be 1, Alia Bhatt will be 2. Like that we can do that. Now
Yeah.
this is a data. This is a class.
Mm.
Here Amitabh
Mm.
Bachchan 0. It's Amitabh Bachchan 0, 0. Like that will become. Then Virat Kohli 1, 1, 1. We are giving Alia Bhatt 2, 2, 2. It will be shuffled. It is not in this order. It will be shuffled. We shuffle the things and it will have the things. Now it is our data set. Now
Okay.
this we call it as an X. This is called as an X. It is a question. Correct? No. And this is answer.
Mm.
I'm showing the one photo. It has to tell who is this person. That is
Mm.
answer. Now 1,000 will be there. Now what we have to do means
Mm.
this thing only we are representing as a four-dimensional. 1,000 comma maybe I'm making 100 comma 100 comma 3. I'll make it. This is represent. This is called X. And how we'll mention this thing? It is a 1,000 only. Correct? No. 1,000 comma 1.
Yeah.
This is called Y. It is a question. It is answer. This is a data structure. Now we are dividing it into 80 and 20%. Then this become that.
Why we are dividing the
Yeah, yeah, I'm
80%,
telling you.
80 by 20?
I tell you. This
Normally, we
80%
are
is
tell like,
um. Tell me. Normally,
yeah, yeah, yeah. Go ahead. Yeah, tell
I'll
me.
complete. Then you can ask the question. Okay. Now it is called a test.
Yeah, okay.
Now your teacher is prepared 1,000 question and answer, and now what is happening means your teacher is dividing into 80% and 20%. Okay, and the model is a student. You are a student. Okay. Now this is called then it is called X train. This part is called X train. This is called Y train, and this is called X test. This is called Y test. Now teacher will give to the student X train and Y train and teach them how to identify when we are giving this question, how to arrive this answer. Like that, we will train the student. So that students will be keep on training, they become saturated. One time they become saturated, they will come for the test exam. During the exam time, what will happen? Teacher will give the only this portion only. They will not give that the Y test. They will not give only this thing only. Student has to give the answers. That is called Y predict. Now, this is a maybe answers will be like this. It is a 1, 0, 0, 2, 1, like that will be there. Now, students are giving the answers. It is a 0, it is a 1, it is a 2, it is a 1, like that they're giving the answer. This is Y predict. It is called Y test. Then we have to evaluate with this answer, with this answer. This is a correct, this is a wrong, this is correct, like that. So that is giving a out of 200, 180 they are predicted correctly means it is a 90% accurate. Then we can able to approve that model. It is giving very wrong 50% only means again we have to retrain the model.
Okay.
Here We are doing the data pre-processing normalization, and we have to create that X and Y we have to create. Then third one, we have to go for a data splitting. In the data splitting, we are giving that X and Y, it will convert into X train, Y train, X test, and Y test. Then fourth one, model building. This model building, I told you, input layer, output layer, like that input layer and the hidden layer. In convolution neural network, we are having that four types of layer. No, all the things we have to build it. Hidden and output. In your output layer, we are having 5 classes, 5 output will be there. Any chance, anyone will come. 5 probability will come. We have to pick that which is having maximum, we have to take it. And fifth one,
Yeah.
model training. For the model training, we have to give that X train and Y train. Then once it's saturated, we have to give model testing. In the model testing, we have to give that the X test. We have to give, we should not give the answer to them, but model will give the answer, that is called Y predict. Seventh one, model evaluation. For model evaluation, we have to give Y test original answer
Yeah.
and model answer Y predict. Then this will give the accuracy score. This accuracy score is satisfied means we have to save the model. If the accuracy score is not satisfied, again we have to rebuild this model. Again, change the input parameter, all these things. Again, we have to train, and up to we are getting the accurate levels like that. You got it, no?
Yeah.
Once this will be fine, means we can able to create a one thing called inference system. It is for
Mm.
the proof of concept. We are giving a one image. That image will be go for a data pre-processing.
Mm.
Then the pre-processed data will go to the saved model. That saved model, we have to load the model, load model. Then this model will give the result. This belongs to whom, like that.
Okay.
These are the steps. So that you want to store your guide means you can able to go with an data collection and the data pre-processing up to
Yeah.
this level, you can show them.
3%.
The pre-processing up to pre-processing, you can show them. Then next time you can go with an data splitting and a model building, like that you can show them. Don't show the trained model. You tell that still accuracy is not
And
coming good. I'm fine tuning, like that you can tell them. Next time you can tell them that I got the
okay.
accuracy and it is giving good. Like that you can tell them and show the result.
Yeah, yeah, yeah.
Got it.
Okay.
I will
Yeah, I
stop
got it.
recording. Up to this, I will stop recording. I will share it to you.